Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to continue with linear equations, but in a little bit of a different format. We're going to learn about scatter plots and trend lines, and more importantly, we're going to learn how to write a trend line, how to write the equation of a trend line to be exact. But first, before we can do that, I've got to explain to you what a scatter plot is. And a scatter plot, gentlemen, is a relation which, when graphed, shows a possible relationship or correlation. When you graph relations, which are a set of ordered pairs, sometimes they will give you a relationship, sometimes they will not. This relationship or correlation can be one of three. If you look at the three scatter plots I gave you, and if you think about it, it's called a scatter plot because look at all these points. They're scattered all over the graph, correct? All right. You look at this first one. This is called a positive relationship or a positive correlation. Why? Let's analyze it. They have foreclosures here. Foreclosures are the unfortunate event of when someone can't make their payments on a house. Unfortunately, the bank takes the house away from them. That's called a foreclosure. And then over here on the y-axis, you have number of household units. Okay? So let's think about this. As foreclosures increase, that means there's more available housing for people to buy houses. So housing units increase as well. This is a positive correlation. What happens in a positive correlation, okay, is that both sets of data increase. As one set of data increases, the other set of data increases. This is a positive correlation. And in this correlation, we're going to learn today how to create a line that can represent this correlation so I can make future predictions. That line is an estimate, but it's an estimate built on facts. So it's a very good indicator of what the future will hold. If you look at the second graph, we have a negative relationship. Let's try to understand what's happening here. In a negative relationship, we have the unemployment rate here and then the percent of college educated. If you think about this, guys, as your percent of college education decreases, doesn't the unemployment rate increase? Guys, do you not see that? As my college education decreases, unemployment rate increases. So what happens here is, and this is wrong, it's not both sets of data increase, that is false. Both sets of data, well, no. In this case, as one set increases, the other set decreases. My bad. I'm sorry about that. That was pretty silly. So again, think about it, guys. As my college percentage of education decreases, that means I'm going down, I'm going down, I'm going down. Isn't my unemployment going further and further to the right? So my unemployment rate is increasing as my college education percentage is decreasing. So as one set increases, the other decreases. And again, we have a trend line here that can predict that relationship. It can predict the future. And then last but not least, we have no relationship. And a no relationship or no correlation, it's not increasing nor decreasing. It has nothing to do with each other. For example, they put the percent of college educated and the pet owners. What does one have to do with the other? I can have 7 dogs and you know, I can not even know how to read. It doesn't matter. I can have a PhD in astrophysics and I'm allergic to dogs and cats, so I don't have any pets. So sometimes there's relationships that just have no correlation at all. So again, positive relationship, as one set increases, the other increases. Negative relationship or correlation, as one increases, the other decreases. No relationship is no relationship. Yes, sir.
So it's basically when the two like things being compared are completely different, or could it be like ones that are similar but they still have like no relationship?
Well, you could have sets of data that are similar, but they have no relationship. But usually it's just completely different. It's like if I tell you, okay, is there a positive or negative or no correlation between your hair color and your height? No, it doesn't matter. I mean, there's people in the NBA who are 6'9" and they have no hair. So it doesn't really matter. Okay? You always try to see what kind of correlation we have, though. All right? So these are scatter plots, and those are the three types of correlations. Now, let's take a look at how to create a scatter plot. Table below shows the number of species added to the list of endangered species and threatened species in the United States during the given years. Graph a scatter plot and determine the type of correlation, if any. Okay. When you are doing this, my friends, it is extremely important to label is exactly right. So I have, first of all, the title. I have to title my graph. And in this case, I'm going to call it species added to the list. Okay? I also have to label my x and my y-axis. You can choose whatever you want here as long as it correlates to the given information. The given information that they have here is the calendar year and the species. So I'm going to make my x the year because the year is independent always. And I'm going to make my y the species. Okay? Now it's very important when you're creating a scatter plot to label this correctly. Okay? Extremely, extremely important. Now I'm going to do this because it's going to be kind of hard for me to go backwards and forwards, but this way we have everything that we need here together. So okay guys, so let's figure this out. Now I want to go ahead and graph this. Well, when I'm graphing this, I'm going to have to label the years. I'm going to have to label my axes. Okay? You're not going to go by ones in this particular case. You have to use your head and you have to use logic. Okay? And you know what? It's going to be easier for me to do this. Let me go ahead and copy this table. Okay, so my year is from 1996 to 1990 to 2002. So what I'm going to do is called a line break. You're allowed to do a line break on graphs when your intervals are different than your starting point. If I was starting with year 0, and then I started counting from there, I don't need a line break. But I'm not going to start with year 0 because that's going to be a lot of lines before I get to 1996. So I'm going to do a line break, and a line break is a little symbol like this. Okay? And that line break indicates, hey, reader, listen up. I'm starting with 1996, but I'm really going to be going in intervals of 1 year. So that's 1996, 1997, 98, 99, 2000, 2001, and 2002. So again, a line break indicates to the reader of the graph, hey reader, I know I'm going by 1 year intervals, but I'm starting in 1996. And then the species. The lowest value is 9, the highest value is 91. Do I need a line break here?
Yes.
No, because I'm going to go by intervals of 10. So here, on my species, I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Is everyone with me so far?
Yes.
So you need a title, okay, and you need to label the graph x-axis and the graph's y-axis. Now, it's easy. In 1996, I had 91 species added. Is this an exact point or is that an estimation? That's an estimation and that's okay. In 1997, I had 79. So that's an estimation as well. In 1998, I had 62. It's about there. In 1999, I had 11. So 96, 97, 98, 99. So in 99, I had 11, which is about like here. Oh, 99, about here. 2000, I had 39. It's about here. And then 2002, no, 2001, I had 10. And then in 2002, I had 9, which is about here. And I messed up. In 2099, it's 11. So 2099 would be about here. Okay. That's my scatter plot. What kind of a relationship do I have here? Negative. Absolutely, because as my years increase, what's happening to the amount of animals that I'm putting on the species list? It decreases. Very good. Now, I can make a prediction with this if I make a trend line. Okay? If I make a trend line. And that is the next skill we are about to learn. Does anyone have any questions so far on how to create a scatter plot? Yes, no, maybe kind of sort of, my brothers. Okay? So now, describe the correlation illustrated by each scatter plot. So for number 1, what's the correlation here? Positive, yes, because I'm going up, right? As one set of data increases, the other set of data increases. So this is a positive correlation or a positive relationship. Yes, sir.
When you start the trend line, do you start from the first?
I'm going to show you how to do a trend line in a second. I'm just showing, making sure that you guys know how to determine if it's positive or negative. How about number 2? Is that a positive, negative, or no relationship? That is a negative relationship because as one of my sets of data is increasing, the other set of data is decreasing. How about number 3? Number 3. That is a positive relationship as well because as one set of data is increasing, so is the other set of data. And then number 4, what would this be? This is a no correlation. And it's a no correlation because it's not, as one is increases, the other is not necessarily increasing or decreasing. And if you see here, if you think about it, they're talking about the math and verbal scores. There's not always a correlation there. Some people are really good at math and so-so at English or verbal. Some people are super good in verbal but so-so in math. So there is no correlation. Yes, sir? Sometimes looking at the titles helps you out, yes. Because, I mean, is there any correlation? Let's look at this positive correlation. The temperature, and then this would be, I guess, the price of cooling. As my temperature increases, don't I have to turn on the AC more often? So doesn't the price of electricity go up? If you look at number 2 here, this is eruptive products of the 1915 eruption of Lassen Park. Okay, you had sulfuric acid, I believe, and then you have this other chemical, which I don't know because I'm not a chemist. But when a volcano erupts, okay, the amount of sulfur keeps going on for days, sometimes weeks. But this other element decreases as sulfur is increasing. That works. And then here, I have hours of study and then Regent scores. Regent scores is a test that they give in New York. And as you study for longer, you get higher scores on the regions. So the labels do help you if you cannot ascertain that information by just seeing the graph. Does that make sense? Good question, son. Thank you. May I continue, my brothers? Okay. Now, identify the correlation you would expect to see between each pair of data. The number of empty seats in a classroom and the number of students seated in the classroom. Yes, sir. It would be a negative correlation. Yes. Why would it be negative? Very good. The more students that are present, the less empty seats there are going to be. So it's the number of empty seats in the classroom and the number of students seated in the classroom. The more people in school or in class, the less seats available. Very good. How about number 2? The number of pets a person owns and the number of books that person read last year. There's no correlation there. I could be an avid reader and not like animals. I could be an avid reader and not have time to own an animal. I can hate reading and have a menagerie of animals. Okay? I can be a farmer and maybe I never read a book in my life. So there's no correlation there. Number 3, the monthly rainfall and the depth of water in a reservoir. Yes, sir. That's a positive correlation. Very good. Because the more it rains, the more the reservoir fills up. And the more the reservoir fills up, the deeper that reservoir is. How about number 4, the temperature in Houston and the number of cars sold in Boston? Yes, sir. No correlation. Has nothing to do with each other. Very good, gentlemen. Very proud of you. How about number 5, gentlemen? The number of times you sharpen your pencil and the length of your pencil. Negative, very good, because the more you sharpen it, that means the smaller it gets, absolutely, because you're shaving off part of the pencil. So that's pretty easy, right, guys? Okay. Now, let's wrap this bad boy up. Trend line. The line drawn on a scatter plot, which helps show the correlation more clearly. It is also helpful when making predictions based on data. I have for you here again a scatter plot that shows the temperature in Celsius and the cost of your electric bill. Okay? The trend line, when you're drawing it, guys, the goal is to try to draw a line that's in the center of all the data. Is it going to be exact, my brothers? No. But you can be pretty close. For example, what does pretty close mean? Okay, do you think I would accept that as a trend line? No, that's not even close to the middle. Would I accept this as a trend line? Not even close to the middle. But this guy right here, yeah, that's pretty close to the middle, man. I got one of the here, 2, 3, and I got 1, 2, 3 above and below. That's roughly in the middle. If I were to tell you to draw a trend line here, okay, let's see, I would say it's about, would that be good? I'd accept it, but better would probably be, let's start from here, let's go about here. That would be a much better trend line, okay? You're trying to go as close as you can to the middle. Yes, sir. Okay, your trend line does not have a curve because it's not called a trend curve. It's called a trend line. But I thank you very much. It's a very good question, son. Very good question. Now, it's easy to draw the trend line. Where the skill comes is writing an equation for that trend line. So when we're writing an equation for the trend line, it goes like this. Using the given relation, graph a scatter plot, draw a trend line, name the type of correlation, if any, and then predict how many miles passengers flew in April of 2008. Okay, let's do this. First of all, what title do you think you would give this scatter plot? Very good. U.S. domestic air travel in April. Very good. That's the title. I have 2 different variables here. I have the year and the miles. So who do you want to call the x-axis? The year. Good job. And then what do you want to call the y? The miles in billions. Okay? This is very important. This is the most important part. You have to label your graph. Label, 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 label. Okay? Now let's see the intervals. The year goes from 1996 to 2002, and the miles go from 37 to 46. So my year 96 to 2002. Me personally, I'm going to use a line break. And I'm going to start at 96 and then go by ones. 97, 98, 99, 2000, 2001, and 2002. And then my y-axis, I'm also going to use a line break. Why am I going to use a line break for that one? Because I'm going from 37 to 46. Okay, so I'm going to start at 37, and then I'm going to go by ones. 37, 38, 39, 40, 41, 42, 43, 44, 45, and 46. Is everyone with me here? Talk to me, gentlemen.
Yes.
Okay, I hope so. So now, let's go ahead and draw our points. So I've got 1996, 37. So 96, 37. I've got 97, 39. 97, 39. I've got 98, 42. So 98, 42. I've got 99, 43. 99, 43. No, that's 44. 99, 43. I've got 2041. So the year 2000. I've got 41, which is here. And I've got 2001, 38. So 2001 would be 38. And 2002, 46. So that's 01, and that's, so 2002, what do we say it was? 46. So 2002, 46 would be about here. Okay, that's my graph. That's my scatter plot. My trend line. I want my trend line to go roughly through the middle here. So what I like to do is I like to find what's called anchor points. A point at the end of the graph and a point at the beginning of the graph that can encapsulate the graph to the best of its ability in the middle. So me personally, I'm going to use this guy, and I'm going to use this guy. And my trend line is going to go right here. That's more or less in the middle. So far I've done a lot of this problem already. I graphed it. I've made the trend line. What kind of a trend is this? This is a positive correlation. Very good. Now the last thing I have to do is write an equation so that I can make a prediction. Well, guys, we already learned this skill. This anchor point right here, that is 1996, comma 37, correct? That's my x1, y1. This guy over here is my other anchor point, which we said was 2002, comma 46. That's my x2, y2. Now from here, guys, how can I make a line? We know this skill already. What do? Very good. We're going to use the point-slope form, using the slope, using the point to find an equation. So first thing I got to do is find my slope. And my slope will equal 46 minus 37 over 2002 minus 1996. So that's going to equal 9 over 6. 6 years. So that's going to equal 3 halves. And that is my slope. Now that I have my slope, let's use point slope form. Y minus y1 equals m times x minus x1. So I have y minus 37 equals 3 halves x minus, I would allow you to use a calculator for this just to make your life easy. Okay, 3 halves is 1.5, so 1.5 times negative 1996 gives me 2,994. Add the 37 to both sides, and y will equal 3 halves x, and then I have this minus, okay, so this is minus 2,957. And that is my equation of the trend line. Now, that's fantastic, Mr. Morrow. Yippee, hooray. What does that have to do with anything? Well, if you looked at the instructions, it said predict how many miles passengers flew in April 2008. Well, I have my formula already. It's right here. So let's go ahead and find out. In 2008, I have y equals 3 halves times 2008 minus 2,957. So I have 1.5, which is 3 halves, times 2008. That equals 3,012 minus 2,957. And y equals 55. And that's in billions. So that would be 55 billion miles. And it makes sense. Why does it make sense, Mr. Morrow? Because you say so? No. Because look at the graph. I have a positive relationship here. So as the year increases, don't my miles have to increase as well? When I plugged in 2008, that's a later year, isn't it? Didn't my miles go up? It made sense. Now, here's a question everyone asks. Mr. Morrow, what if I use different anchor points? I promise you, if you do it correctly and your trend line is somewhat in the middle, you will have about that answer. Okay, what does that mean? On a test or on a quiz, if I went ahead and gave you this question and I gave you 55, I give you a leeway of about 3 points both ways. So if you got 52 to 58, that's an acceptable range and you would have the right answer. What am I really looking for though? That you made the graph correctly, that you do the trend line in the right location, that you labeled the x and y axis, that you use your intervals correctly, that you found your slope correctly, that you use the point slope form correctly. That's what I'm really focusing on and looking at. Does that make sense, gentlemen? Any questions, gentlemen? Guys, thank you very much. Hope you learned a lot, and I hope you have a great day. Take care, and bye-bye.